In this discussion video, we'll do some practice problems where we recognize sums as integrals. So each of these integrals can be thought of as an area under a curve, and we want to figure out what the underlying function is and what the interval is over which we're finding the area. So this is problem number 8 from worksheet 13, and we're going to eventually do parts B and E of this example. But I want to first recall our formula for the exact area using a limit of Riemann sums. So remember that the picture was something like, if I have my axes and we have our function, so I'll call this y equals f of x, and we have some interval from a to b, we first split this up into n subintervals. So I'll draw some tick marks. And then we use right endpoints to approximate this with the rectangles. So the first subinterval rectangle looks like this. The second one looks like this. And I'm going to do the rest quickly. Okay, so there are the rest. And then we label these tick mark points. So the A, we call that x0. Then the next one we call x1. The next one is x2. And we keep going like this. And the rightmost endpoint, where B is, we call that x sub n. Alrighty, and the length of one of these subintervals, we call that delta x. Okay, so remember that delta x, our formula for this in general, the way we get it is we take the length of the whole interval, which is b minus a, and then you divide that by the number of rectangles you're splitting it up into, which is n. And that's our formula for delta x. So to get the exact area of this, what we're going to do is we're going to add up the areas of these n rectangles and then take the limit as n goes to infinity. So we're essentially going to take an infinite number of rectangles. Okay, so writing that out, we get the limit as n goes to infinity, the sum from I equals 1 to n, and then we get delta x, which is the base of one of these rectangles, times f of x sub I, which represents the height. Okay. So remember how we figure out what x sub I is. The way we do that is we write out the first few of these x values. So in this picture, x0 is a, whatever that leftmost endpoint of the interval is. x1 is a plus, I gotta add delta x to it. x2 is a plus, we would have to add 2 of these delta x's to it. And if I keep going like that, in general, x sub I would be a plus I of these delta x's. All right, so I want to keep that formula in mind. So this is going to be our formula for x sub I in general. Okay, so let's look at a practice problem. We have part B, which is the limit of this Riemann sum, and I want to figure out what is my underlying function, what is the interval over which we're taking this area. So I want to give you 3 minutes to try this first. So pause the video in 4, 3, 2, 1. Pause it and try this for about 3 minutes first. That may not be enough time to finish the question, but hopefully you're going to think about what are some of the key ideas and getting started with the problem. All right, let's go ahead and talk about it together. So to answer this, I want to match up parts of our problem to the general formula. So if I compare what we have to the general formula, it looks like the delta x, that resembles this 2 over n term. So this makes me think of delta x. And then the rest of this is going to match up with that f of x sub I. So this is going to be the f of x sub I. So from that, we need to figure out, well, what is the underlying function f of x? And then what is the x sub I that's being plugged in for the x? So looking at this, this seems to be something squared. So I think maybe the underlying function is x squared. And then the x sub I, the thing that's getting plugged into the x, looks like 1 plus 2 over n I. Okay, and if I compare that to our formula that we have for x sub I, which looks like a plus I times delta x, well, this looks like the a. And the 2 over n, that looks like the delta x. So we have a plus delta x, and then times the I. Okay, so at this point, it seems like we have the delta x, we have the a, we have the function, we just need the value of b. Okay, so the way we get that is from delta x, this tells me the interval length. Because remember that the numerator of delta x, that was how long the whole interval was. So the interval length is going to be 2. That's our numerator here. Okay, so knowing that our interval starts at a, which is 1, and the interval length is 2, well, that tells me the value of b. That means the other endpoint has to be 3, which means this is an area under the function f of x equals x squared over the interval from 1 to 3. So this wasn't the only way that we could have set this up. Looking at what we said our f of x sub I was, we could have also said our underlying function was, maybe looking at this, maybe we thought it was something like 1 plus x, that whole thing being squared. And that would also work. If that's what we thought f of x was, our x sub I would have been, we wouldn't have needed the 1 in it. It would have just been the 2 over n times I. And from this, well, there's nothing in front of the 2 over ni, which would have meant that the a value was 0. The length of our interval still would have been 2. That would have made the b value be 2. And all that would do graphically is this plus 1 would have shifted the graph over by 1 unit. And then the same thing happened with our interval. It goes from 0 to 2 now, which is 1 unit shifted over from what we got. So it still would have represented the same area. So I'd encourage you to draw a picture just to convince yourself that that is the case, and that it will be the same area. Okay, well, let's move on to the next part of the problem. Okay, so I want to look at part E. For this question, I want you to pause it for 4 minutes to try it on your own first. 4, 3, 2, 1, pause it and try it for 4 minutes. All right, so hopefully you did that. Hopefully you paused it and tried it for 4 minutes. Let's talk about it now. So with this function, I'm going to rewrite this first. Because one of the things that made it easier for me to be able to match what I had in the previous problem to the general formula was that I need my delta x to look like some number over n. But over here, we have some number over n to the 3 halves in front. Okay, so what I'm going to do is I'm going to split up that first fraction as being 1 over n times 1 over n to the 1 half. And then we have times this square root. And then n to the 1 half is a square root. This is squared n. So what this gives us is, we have that 1 over n, and now I'm going to bring this square root of n that's on the denominator into this fraction, into this other square root. That'll give me the square root of, let's see, n plus I on the top and n on the bottom. So this becomes 1 over n times the square root. And if I split up this fraction into n over n plus I over n, we'll get 1 plus I over n. And now my expression looks like something that I can match. So what we have is we have the limit as n goes to infinity, the sum from 1 to n of 1 over n times square root of 1 plus I over n. Okay, so this 1 over n, that matches up with the delta x. And that means this square root term matches up with f of x sub I. From that, I need to figure out my underlying function f of x, and then the x sub I that's getting plugged in. So looking at this, it seems like my underlying function is square root of x. And then what's getting plugged in would be 1 plus I over n. And I'm going to rewrite the I over n as 1 over n times I. That way, I can see that this 1 represents a. This 1 over n represents, that's my delta x, and then we get times the I. Because now I can see this x sub I matches, it matches our general formula for what x sub I should be. Okay. So from here, I know my f of x, I know my value of a, that's 1, I just need the value of b. So from delta x, this is going to tell me how long my interval is. So our interval length, remember that's just the numerator of delta x, that's going to be 1. Okay, and because I know a is 1 and the interval length is 1. That means the right endpoint, B, is going to be 2. So this is the area under f of x equals square root of x, that function, over the interval from 1 to 2. And that is our answer.